Hi everyone, this is the Big Data Analytics final project presentation from Group 13. Our topic is Anime Recommendation System. I am Yifan Wang. Anime usually refers to animation produced in Japan. The anime industry has been developed quickly since last century. Watching anime has been a popular choice for people of all ages in the whole world. We did a deep study into the various recommendation algorithms and mathematical models that suit the purpose of recommending animes to the anime lovers just like me. Content-based filtering and collaborative filtering are two different algorithms can be used in anime recommendation very well. The next part will be introduced by my teammate Hanwei Tang.
The first step of our project is to get the data of the anime. As we know, many websites will keep the privacy of users, so user data can not be read easily. However, we find that the user's preference data can be found on myanime.list.net. So we get the big data of anime through the Gcon API, and we encoded the username by ourselves. For anime information, we got the anime ID, name, score, genres, type, and other things. For users information, we got encoded the user ID, score for each anime, and the watching status. Next, let's see the data virtualization. As we can see, the for the anime genres, comedy and action are very popular. And as for the anime types, TV and OVA are also very popular.
Now, let's talk about how we can approach to the anime recommendation system. To approach anime recommendation, we use two different algorithms, content-based and collaborative filtering. And what is content-based and collaborative filtering? And what is the difference between them? Content-based is using item content itself, like genre, anime type, or any other things in this case, to feed the model and generate recommended result. And for collaborating filtering algorithm, it's generally predicting what users will like based on their similarity to other users. The key to collaborating filtering algorithm is to find the user preference for each item. And we use different modules like NumPy, Pandas, TensorFlow, and also UI Spark in order to approach to different algorithms in this case. Now let's talk about mathematical models we use in our system. We use KNN model, which is very broadly used in content-based algorithm recommendation system. And we use this model to predict the similar anime to the anime and finding the similar animes, the closest animes to the anime specific one. And also we compare four different regression model: linear regression model, random forest model, decision tree model, and gradient boosted tree model in order to predict general score for different animes. And let's see the result here. For KN recommendation, we pick up a random anime and we can see the result, the four closest animes to the specific anime. And now let's see the regression model accuracy in predicting scores. We can see on the graph, the linear regression model is actually the best model for predicting general score for different animes. Now let's talk about the deep learning neural network model for the recommendation system. We use this model for our collaborating filtering algorithm. Why we are using deep learning neural network model? Because for finding user preference, like finding the rating score for different anime for different users is actually very precise job to do, and only the neural network will make this system more precise and accurate. And here is a simple system we built in our first draft. So we use a user and item data and put them into two different embedding layers. And then we use dot product for two different layers in order to let them the data inside themselves communicate with each other. And then we can output the prediction result. And because for a normal neural network, we normally will add more hidden layers into system. So we adding more hidden layers into system, making them more complex. The system becomes more complex, and let's see the result here. For simple neural network model and more complex neural network model we build here, we can see that the upper bound of the model accuracy didn't change very much. Both of them haven't reached 0.45 accuracy here. And they are all above 0.44. So then we can get the conclusion here. Adding more hidden layers won't make it will make system more complex, but it won't increase the upper bound of the whole system. However, it will increase the speed how you get the upper bound of the system. So in order to approach a better system here, we did an experiment. We added more metadata information into the network and see what's the result. So in this case, we can see the general guide diagram on the left side of the presentation here. So instead of using city, age, or other non-relevant metadata, we used episode watched and the watching status of different animes for different users here. We add two metadatas into two different embedding layers and combine all of them into the system and let them communicate with each other. And I also added a few more dropout layer into the system in order to get rid of the overfitting. Then we can see the result here. The result is quite impressive. For the whole system, it easily reached the 0.489 accuracy. This is very impressive because I only added two metadata into the system. Normally, for the commercially use, we will add many more metadata into the system, and we can see how obvious the metadata will improve the system here. So why won't added more metadata by ourselves in this experiment? Because adding more metadata into the system, it means we need more processing time, and also we need more budget for GCP. So using the DL model we mentioned before, here we use the prediction of personal rating for different animes. Of course, that is for the anime you haven't watched in this system. And we sorted up and find top 5 anime recommendations for each person. And here is a random user, and we find the anime for him. Now, we used the multi-class evaluation in PySpark to evaluate the content-based accuracy. And for deep learning, we use ADAM optimizer and cross-entropy metrics in TensorFlow to monitor the accuracy in the system. Now, here is the CF method progress here. Getting data and spread the data and pre-processing them into 4 different layers, and using 4 different layers, train the DL model and predicting personal ratings for different animes, and sort the ratings and then recommend top rating animes. And for our whole system progress for a workflow, we get data by scraping a process, and then we use two different methods: content-based method using KN to predict similar animes for each animes, and using linear regression to predict general score for each anime. And then for combining the two results we get here, we can recommend an anime to new users here. And for the collaborative filtering method, we use deep learning neural network to predict the personal score for each anime, and then recommend the anime to the old users. So let's talk about future improvements for this whole system. You can see on the graph on the left side is wide and deep system, which is generally used by Google company. And on the right side is generally used by Facebook. And we can see the system is more complex and have some difference between ours with our system. And what is good thing about their system instead of using ours? Because first they have more metadata here, like here, they have more metadata, and they're using more metadata and making the system more accurate. And also they're very clever to use the elements-wise multiplication. Here we can using this method, we can let embedding layers cross communication with each other. The data will cross communication with each other before getting to the hidden layers or hidden nodes here. So the complexity of the system increases much more. In order to approach their system, also we can get a different kind of method, like using RNN layer. We pick up a sequence of data that user provided, and using RNN layer, and then putting into the hidden layer or cross communication like this is also another method. So the general idea here is, in order to get a more accurate and complex system, first we need more metadata. Also, we need metadata to cross communicate with each other before any communication into the hidden layers. And for the conclusion here, the linear regression model is the best model we pick up for the predicting general score. And deep learning neural network are very suitable for predicting each user rating. And also, we found out that adding more metadata into the system will, obviously improve the system accuracy. And for the business value here, providing a personalized anime recommendation system for the anime website. We use my anime list website in this case, but it can generally broadly use in any other website. And also the system can apply to any static database instead of just anime database, but you have to do more work on the data pre-processing. And also for the content-based filtering recommendation is more widely used in commercially. Why is that? Because first, it's very simple, and the progress time is very small. So, and also for the new users, the CF algorithm won't help very much. So instead of broadly using CF algorithm, we can see more content-based filtering in our real life. And also content-based filtering can be, more easily manipulated. Like you can add, a simple parameter like the sponsorship into the system, and you can get a completely different prediction result. And then you can let your sponsors be broadly recommended instead of just nobody else you want to see. And yes, that's it. Thank you very much for listening.